Welcome back. So we're on exam domain 1.4. And exam domain 1.4 talks about disaster recovery solutions for SAP on AWS. And previously we talked about high availability solutions, we talked about overlay IP, but now this session is going to focus on disaster recovery. Before we get to the actually talking about some of the criteria and the actual patterns that are available for you guys, let me just get to that starting point. So I want to quickly sketch out the HA stuff and then move on to the DR stuff as they are part of the same domain. Okay, so HJ's in, but let's start talking disaster recovery. Now, before we start looking at specific architecture patterns on the light board, we need to understand what are the key criteria or key units of measurement in terms of deciding which strategy or which architecture pattern makes the most sense. So the first one I want to talk to you about is recovery point objective, abbreviated as RPO. And this is the amount of acceptable data loss a business is willing to accept or tolerate in the event of a natural outage or a natural disaster, for example, or some form of outage. The second one I want to mention here is recovery time objective. So if we drop that in right here, so RTO is the acceptable amount of time that a business can accept their IT systems being out of action. So in this case, these SAP environments, which could be business critical, how much time, what's the acceptable amount of time that they can be out of action, and what's the acceptable amount of time that they need to be recovered within. So that's RTO. And then the final one I want to just add here is around cost, okay? So RTO, RPO versus cost. So the different architecture patterns will have different RPOs, RTOs, and there'll be a different cost associated with them. So we'll look at each of these as we go forward. So the first architecture pattern we're going to look at is passive DR. Now passive DR is all about restoring your systems, your primary systems in your secondary region. So let's drop that region in right now. So you can see I've got my secondary region, and it's restoring all of those systems from backups. Okay, so as we already discussed previously, our backups always go to an S3 bucket because we have HANA backend agent installed and so on. So let's drop that bucket in right here like this. So all of our backups are going to the S3 bucket. Let's give it a handle. And then with the S3 bucket, we have a secondary bucket in our secondary region, right about here, like this. And we have cross-region replication enabled between the two buckets. So S3 cross-region replication, CRR, is running between this bucket and the secondary bucket in the secondary region, and all of our data and backups are being replicated across to that bucket. In addition to that, we can have AMIs of our app servers and ASCS, for example. So let's drop those in. Now, this is great, right? Because we're only paying for storage. So the cost of this approach or passive DI is very low because we're only paying for the storage costs of all of our backups. However, the time it takes to recover these systems is going to be much higher because we're restoring from the backups and the AMIs. Does that make sense, right? So let's actually jot this down on the board. Okay, so for passive DR, because we're restoring from backups, it depends on the frequency of those backups and the frequency of the log backups, for example. We're looking at RPO of hours in terms of the time it takes to recover these systems. Again, you're looking at hours, but the cost for restoring, the cost of this approach is very low. So we have $1 sign just for passive DR. The second architecture pattern we're going to look at is pilot light, okay? So this is where we look at which components of our architecture are the most critical, and usually that will be the database. So what we're going to do is we're actually going to drop in a smaller EC2 instance. So well, let's just draw it a little smaller as well, actually. And this is going to be a HANA node, okay? Now the purpose of this is basically to simply just replicate the data from our primary region to our secondary region. So we have HSR active, or we have replication active. This is asynchronous with preload off, and that's because this is a smaller size HANA system instance. This is not a production size instance. It's smaller, it's cheaper to run than our production instances, and it's only doing replication to disk, to EBS volumes, okay? And that's the purpose of that. So we have a small instance running. We can restore our application tier again from our AMIs. The question then comes in is how does that affect the RPO, RTO, and the cost? Okay, so for Pilot Lite, you can see the RPO is minutes now because we're having active replication, 2 EBS volumes in our secondary region. Now, in the event of an outage, you would have to upsize this HANA instance to a production size instance and then load all the data from EBS volumes into memory in the case of HANA. And you would restore your application tier from the AMIs, which is why the RTO is still hours potentially. I mean, you can apply automations to help minimize that, but you're still looking at hours potentially. Now, the cost factor here is this is slightly more expensive than passive DIs because you have an active instance running in your secondary region, which is taking care of the replication to EBS volumes. Remember, it's asynchronous with preload off. The third architecture pattern we're going to look at is warm standby DR or hot standby DR. So let's just actually start looking at this. And this is where we have, instead of having a smaller size instance like Pilot Lite in our secondary region, we'll have a production size instance. So this is a HANA production size instance with asynchronous replication, preload on potentially because the instance can take, has enough memory to hold the data in memory, for example. And then from the application tier, we'll have some active application tier nodes. So basically, you know, potentially an ASCS running up here, and even some application servers running, not maybe the complete set from a warm DR perspective, ASCS, and some additional application servers. But when we talk about hot DR, you would have the complete set of application servers active. And again, how does that impact your RPO, RTO, and the cost? So warm DR, we're looking at RPO of seconds because we have a HANA production size instance doing async replication with preload on. We're talking about RTO of minutes because we have the SCS node in place. We have a subset of application servers in place from a warm DR perspective. In a hot DR, it may be less than a minute, for example. When we talk about cost, we have active nodes running in our secondary region. We have a HANA production size node running, application tier nodes running, with ASCS running, so the cost is significantly higher. So it's really important to understand RPO, RTO versus the cost based on customer requirements. Okay, please like the video. Make sure you repost it. Shout out to Vamsi as always. Join me in my next group of videos around exam domain number 2, and I'll see you guys all then.